In the previous lecture, we started with chapter 4, and we said that our aim in chapter 4 is to deal with higher order differential equation. If you still remember in chapter 2, our aim was first order differential equation and solving it. So first, we understood first order differential equation when it has unique solutions and so on. And then we learned methods to solve it. Here we will do exactly the same. So we started with chapter 4 in general by talking about linear higher order differential equation. We divided it into two parts, homogeneous and non-homogeneous. And we talked about when can we say that an initial following problem has unique solution. And we talked also about the n parameter or fundamental set of solutions. Our main objective for today is to solve nth order linear homogeneous ODE with constant coefficients. It means that before y double prime or before y triple prime, we should have a constant, before y prime constant, and so on. And we will solve only the homogeneous. In order to understand this factor, all what we need is something, how to find roots of polynomial and how to find or to deal with complex numbers. We'll start first with auxiliary equation of second order linear differential equation. Again, our aim is with which differential equation? Second order with constant coefficients. It means that these A, B, and C are numbers like 2, 3, 0, negative 5, negative radical 2, and so on. Our solution is to form y equal e power mx, and our aim is to find out how many independent solutions should we find for this one. This is the second order. How many independent solutions should we find? 2. So we should get 2 values per m, right? We will substitute y equal e mx. We'll get this one, e power mx times this one equal to 0. E power mx, could it be 0? Exponential, could it be 0? Okay, so what's this 0 now? am squared plus bm plus c equals 0. And this one, what do we call it? Auxiliary equation. Okay. If we have a quadratic equation, what are the possibilities for the roots to be? Usually you find the delta, right? What are the possibilities for delta, miss? If we have a quadratic equation, how do we solve that? What do you find? Yeah, but how do you find variables variables? Did you take the delta miss before? Discriminant? Is delta equal b square minus 4ac? Yeah. Okay, so what are the options for delta miss? Either positive or negative or what? 0. If it's positive, how many distinct roots do we have? 2 distinct real roots. And if it's negative, we have complex roots. And if it's equal to 0, what do we have? Double real roots. Anyways, we can solve it also using the calculator if we don't want to use the delta for it. Okay, so what are the cases that we have for the solution? We can have distinct real roots. So the solution will be e power m1x, e power m2x, and the linear combination of it. In the case we have double root, it means that m is reflective. We need 2 independent solutions. Can we write the 2 independent solutions as emx and emx? Can we write both of them as emx, Abu Zaid? But we are saying independent. If you wrote them both, the round skill would be what? 3, right? We want them independent. So to remove the dependency, we multiply by what? By x. And the last case, if it's complex, it can be written in this way. Please, miss, write this one because this slide will use it for all our exercises. Here we have three examples. We'll start with the first one. What I need from you to do is just write this one now. Just write the differential equation. 2y double prime minus 5y prime minus 3y equal to 0. So this is a second order differential equation with constant coefficients, right? We have 2y double prime minus 5y prime minus 3y equal to 0. This is linear with constant coefficient, right? So this one is homogeneous, linear, second order, and constant coefficients, right? What's the auxiliary equation of it, miss? Instead of y double prime, as if what do we have, miss? And square. Instead of y prime, and instead of y, nothing. Is it okay, miss? Okay, just make sure that we understood it. I will zoom here a little bit. The auxiliary of this one, Abdulrahman, of part B.
And square.
And square.
Minus and plus
Equals?
equals it.
Okay, Ali, what's the auxiliary equation of part C?
Plus 4m plus 7m equals it.
Plus 7. Instead of y, we have nothing. Okay, miss? Oh. Now, this one, we want to solve it. We have more than one option, and you are free. You have the right to use any of the methods, either use the delta factoring or the factoring. So what do we need to use? What's M1 and M2? M1 is equal to what, miss? M1 equals 3. Minus half. Okay. What will be the solution now? Y equals C1 e power M1x 3x plus C2 e power M2x. Is it okay, miss? Okay. Now let's do the second exercise. The second example is y double prime minus 10y prime plus 25y equals 0. Let's think about this exercise, miss. Again, our first step might be auxiliary equation, but of course the auxiliary equation is under which substitution? So in order to get the auxiliary equation, what do we use? Y equal EMX. So here y equal EMX, and you will check the cases for M that we will get, and you will find the auxiliary equation. So I need each of you to write the auxiliary equation. The auxiliary equation, Ahmed. The auxiliary equation, m square, okay.
Minus 10m
Okay.
plus 245.
Okay. Now this one, if we factorize it, or we use the delta or the calculator, I will factorize it, but if we use the calculator, we get m minus 5 equal to 0. So here, which case do we have? M1 equal M2 equal 5. So what did we get here? Double the real roots, right? Right. So how do we write our answer next? Because this is case 2, our answer will be y equals c1 e5x plus b2 e5x. How do we remove the dependency? We will multiply by x. Okay, miss? Can we write c1 e5x plus c2 e5x, miss? Can we write that? Abdulrahman? Why? Because they will be dependent. To remove the dependency, please put it as an alter. To remove the dependency, we multiply by what, miss? We multiply by x. We need now to check this one. Y prime plus 4y prime plus 7y equals 0. So our first step, and when we have constant coefficients, we'll start as y equal emx, then write our auxiliary equation. What's our auxiliary equation, Smiley? Okay. Okay. Equal. Yes, you can use delta to solve that, or use the calculator. We want to use delta. Delta equal b square minus 4ac, which is 4 square minus 4 into 1 times 7. We'll get 16 minus 28. 16 minus 28 is equal negative 12 less than 0. So what did we get here? Complex roots. What are the complex roots? M equal minus b plus or minus radical delta over 2a. So M is equal minus b means minus 4 plus or minus I radical 12 over 2, which is minus 2 plus or minus I radical 12 is I radical. Okay. If you want to use the calculator, also you can use the calculator, but this is using the method. Let's rewrite M here. This equal minus 2 plus or minus I radical. This one is alpha and this one is beta. Okay, miss? This is the case of complex roots. So what's y? E have alpha x, C1 cosine beta x plus 3 sine beta x. Y is equal. What's alpha? Minus 2x. And what's beta? And this will be our final answer. Do we have any questions so far? This is second order. But if we go back to our objectives, it wasn't about just second order. We need also to deal with third order, fourth order, and so on. So also it will be the same method. If we have linear homogeneous with constant function, y triple prime with the set of L and Q, y fifth prime, and what? Y fifth prime, what should we put instead of it? If y double prime, we're putting m squared, y prime m, y triple prime m cube. So y fifth prime, what should we put? M power. Okay, miss? So in general, the n prime of y will put instead of it m power. Now the calculator can solve for us second and third order. We need to use our methods in order to solve the outputs. Okay, so the first thing that I will write here, we may use the delta. So if we have a m squared plus bm plus c equals 0, delta is equal e squared minus 4ac. M equal minus c plus radical delta over 2a. This is m1 and m is minus c minus radical delta over 2a. These are the roots of it. If we have it possible, two distinct real roots equal 0, we'll get double roots. And less than 0 will get complex roots. Please think about this exercise. Write the auxiliary equation for it first and solve. How many roots should we have, Miss? What's the order of this one? So how many roots? 3. What's the auxiliary equation? So y equal e power mx auxiliary equation and q plus 3m squared minus 4 equal to 0. Okay, how did you solve it? You tried to solve it using the calculator, right? What did you get using the calculator? Okay. Calculator. It gives us m1 equal. Okay. Again, what's the order of this one? 3. Degree under 3. How many roots did you get using the calculator? Standards and statements, right? This missing root, it means that it can be either 1 repeated or minus 2 repeated. How do we know this? Any idea? One root is missing. One of the roots. Okay. Occurs twice. We need to know which root occurs twice. Any questions so far? Please think about which root should be occurring twice. Do we still remember this one from algebra? If we have a root, it means that m minus a is a factor, right? Okay. Here, what are our roots? m1 equal 1 is a root, and m2 equal negative 2 is a root, right? So m1 equal 1 is a root. It means that m minus 1 is a factor, right? And m2 equal negative 2 is a root. Means that what do we have? M plus 2. So m cubed plus 3m squared minus 4 is equal m minus 1, m plus 2, and times something. This is something we need to find it, right, miss? So this is the factor. And this one. This one that is here, it should be either m minus 1 or m plus 2, right, miss? M plus 2, you got it, okay. So it should be either m minus 1 or m plus 2. How do we know which one is true? We have two methods here. Either you try the first and try the second and check which one is equal, or you use long division. So here we are saying m cubed plus 3m squared minus 4 equal m minus 1 times m plus 2 times something, right, miss? So what can we deduce about this something? It's equal m cubed plus 3m squared minus 4 over m minus 1 times m plus 2. Right, miss? This one now is equal to what? M cubed plus 3m squared minus 4 into. We can expand, right? How do we expand, miss? M squared plus 2m minus m is plus m minus 2. Then we apply long division. So here we will put m cubed plus 3m squared minus 4. And here we will put m squared plus m minus 2. And here we will find it. Cube over m squared is m. M times m squared minus m cubed plus m squared minus 2m. Then what do we put here? Minus. 3m squared minus m squared is 2m squared minus 4 minus 2m. It means that minus 4 plus 2m. Okay, miss? 2m squared over m squared is plus 2. 2 times m squared, 2m squared plus 2m minus 4. With the negative, what did we get? 0. So what's our root? What's our factor? M plus 2, right? Miss, if you are familiar with another way to find the long division, do it, miss. So the factor is m plus 2. It means that m cubed plus 3m squared minus 4 is equal m minus 1 into m plus 2 into our apple. It was do we have any questions so far, miss? What are the roots? The roots now are m1 equal 1, m2 equal negative 2, and m3 equal negative 2. What will be the solution, miss? Y equals c1 ex plus c2 e negative 2x plus c3 e negative 2x. How do we remove the dependency? Multiply by x. question? Do we have that question? And to make sure that everything is clear, we go for an in-class activity and then we will solve other exercises. Please join this, join by the QR code. Who's not yet? Who haven't joined yet, miss? Okay, all of us are. The auxiliary equation of a homogeneous ODE is m power 4 equals 0. How many independent solutions should we have here? 4, right? Okay, so it means that m equals 0, it occurs how many times? 4. So the solution is e power 0x, right? Which is 1. How many ones do we have? 4 ones. The first time to remove the dependency will multiply by x. So I have 1, I multiplied by x. I got the second one, I multiplied by x again. I got the third one, multiplied by x again. I got the fourth one. So this one should be the answer. This one is correct for what? If we have power 5 equals 0. So it occurs how many times? 5. We need the auxiliary equation of this one. Auxiliary equation of this one, it will be having distinctly roots or double roots or complex roots. Okay, let's all answer it correctly. We need to, which of the following is true about the Roskin of dependent solutions? Perfect. Dependent solution, it can be axis dependent. What should be the answer of the Roskin? 0. The auxiliary equation of a homogeneous ODE is m squared plus b equals 0. What will be a general solution for it? We will solve similar to it. I would say, not the normal. Let's think about this exercise. We need to solve y prime plus 16, y prime equal to 0. Okay, miss? Y triple prime plus 16 y prime equals 0. How do we start? Y equal EMX. Auxiliary equation is MQ plus 16M equal to 0. Can you write this one as M into M squared plus 16 equal to 0? We took the M common, right? What can we say here? M equals 0. And this one, M squared plus 16 equals 0. What does it imply? M equal plus or minus 4. Right, miss? Do all of us agree? This one, what does it imply, miss? E power 0x, which is 1. And this one, what does it imply? This is alpha equals 0 and beta is equal. So this one, it implies E power 0x cosine 4x and E power 0x sine 4x. Right, miss? And again, E power 0 is what? E power 0?
1.
1. How do we write now our solution? Y equal A1 times 1 plus D2 cosine 4x plus D3 sine 4x. Do we agree on that? Do we agree to write it in this way? Any question? E power 0. What's E power 0? Let's look at this one. What do we have here? Think about this exercise now. How many independent solutions should we have, Miss? But Miss, can we make it sixth order? Just a second. And put here MQ. How many independent solutions should we have here, Miss? 6 independent solutions. So MQ into M minus 2 and M squared plus 16 equals 0. This one, M1 equal M2 equal M3 equal what? 0. How did we know that it occurs thrice? Because power 3. If it's power 5, how many times? 5. This one will start with 4 now. M4 equal 2. If we have power 3, we will get M4, M5, and M6. And this one, what does it imply? Already we solved it. M equal plus or minus 4. This one is here. Again, it gives us E power 0x, right? Which is equal to 1. It occurs 3 times. So the second time also it occurs, and the third time it occurs. How do we remove the dependency? But here I cannot just multiply by x. Okay. The second one, this one, what does it imply? E2 x. And this one, what does it imply? Cosine 4x and sine 4. Now we need to write all of them together. Please write the general solution now. The general solution now. Y equal C1 plus C2x plus C3x plus C4 e power 2x plus C5 cosine 4x plus C6 sine 4x. Means 4 prime. Means that we are differentiating the 4 times. Please think about this exercises each to the. Let's take a few minutes to solve it. So what's the auxiliary equation? Let's auxiliary equation after we put E y equal EMF, it is M4 plus 2M squared plus 1 equals. The calculator doesn't solve for order, so this one we have to check if we are able to factorize it. Are we able to factorize it?
Is that 2 of them or times?
Just want to ask a double prime, I should do. Please add this one as double prime. So this one is, can I write it for plus 1 squared equal to 0? Please check if we can write it in this way. Are we able to write it in this way?
Yes.
This is a remarkable identity. So also a squared plus 2ab plus b squared. This is a remarkable identity. A plus b squared. Okay, how do you continue on? What does this one mean? So we got here m squared plus 1 squared equal to 0. What does this one mean? M squared plus 1 equals 0. How many times does it get? Twice. Why did I write it twice and not 3 times? Because it's power 2. If m squared plus 1 power 3, you write 3 times. Now this one, what does it imply? What are the roots for this one? M equal plus or minus R, right, miss? M equal plus or minus I. What's alpha here? And what's beta? Alpha is equal to 0, right? And beta 1. What will be the solution then for this one? Cosine x and sine x. Is this enough? Is this one our final answer? What do we have with this? So again, what should we write? We should also write cosine x and sine x. Can we repeat the same solution? How do we remove the dependency? Multiply by x. Do you have any question? Okay, how do we write now the final answer? Y equal C1 sine x plus C2 sine x plus C3x sine x plus C4x. Any questions, Miss? I will highlight some questions to start with. Each together, they solve these ones while I'm taking dependencies. Differential. If we get this one on 4x squared plus m equals 0, we can take m in common. So how many roots did we get here? M equals 0 and m equals negative 1/4. Did all of us get it this way? Here, what did we get? M squared plus 9 equals 0. What's the solution that you get? C1 cosine. Who solved the second one, Miss? Okay, the first one was solved and what's the solution that you got?
You really need.
Power?
By C2.
Plus C2, yes. Again, if we go back to our main objective, it was to solve nth order linear homogeneous differential equation with constant coefficient. The only method that we learned to solve it is what method auxiliary equation. If it's complex, we know how to deal with it. If it's simple, we know how to deal with it. And if it's repetitive, we know also how to deal with it. Do we have any questions? Have a nice weekend and happy holiday. See you hopefully after the vacation.